The mind map illustrates various aspects of the Kubernetes Kube-Proxy, breaking down its main functions, modes of operation, related networking concepts, and alternatives. Here's an explanation of each section. 1. Functions. Service networking. Kube-Proxy plays a crucial role in managing the network for services in a Kubernetes cluster. It routes traffic to the appropriate backend pods based on service configuration. Load balancing. It provides basic load balancing by distributing network traffic across multiple pods that back a service, ensuring even distribution of requests. Traffic routing. Kube-Proxy sets up network rules to direct traffic to the correct pod. It ensures that requests sent to a service IP are forwarded to the right pod instances running the application. R2. Modes of operation. IP tables mode. In this mode, Kube-Proxy uses IP tables to manage routing rules for network packets. It sets up rules to determine which pod a service request should go to. IPVS mode. IPVS, IP Virtual Server, is an alternative to IP tables that provides more advanced load balancing features and better performance for large clusters. It uses a similar approach, but with more efficient traffic management. User space mode, legacy. This older mode uses user space processes to forward traffic. It's less efficient than IP tables or IPVS and is rarely used in modern Kubernetes setups. R3. Networking concepts. Cluster IP, the default type of service that makes the service accessible only within the cluster. Node port exposes the service on a specific port on each node in the cluster, making it accessible from outside the cluster. External name maps a service to an external DNS name, allowing the cluster to route traffic to external resources. Load balancer integrates with external cloud load balancers to provide a publicly accessible IP address for the service. 4 limitations. Basic load balancing features. Kube-Proxy provides round-robin load balancing, but lacks advanced load balancing features like weighted distribution or health-based routing. Latency in large clusters. In large-scale clusters, using IP tables mode can introduce latency due to the large number of network rules, though IPVS mode helps alleviate this issue. R5. Alternatives. Service mesh, e.g. Istio. Service meshes offer more advanced traffic management features, such as traffic splitting, retry policies, and observability. Ingress controllers. These manage external access to services and provide more flexible routing and load balancing options than Kube-Proxy. Summary. The mind map provides a comprehensive overview of Kube-Proxy's role in Kubernetes. It highlights how Kube-Proxy handles service networking, manages traffic routing and load balancing, and integrates with different network configurations. While Kube-Proxy is essential for basic service functionality, its limitations in load balancing can be addressed using more advanced alternatives like service meshes or ingress controllers.